Hello everybody, I am downstairs working on math, trying to make sure that the math program is awesome for you, okay? So today, I want you to go to page 159 in your journal, okay? Page 159, page 159 in your journal, okay? Okay, page 159, page 159 in your journal. Okay, I want everybody to go to page 159 in the journal, okay? And then we're going to look at some things, all right? So, why logarithms? I mean, what is the whole point of logarithms? Well, here's the key to logarithms. They allow us to solve for x if x is in the exponent. Like for instance here, you can't divide by 16. That just doesn't work. It's not 16 times x, it's 16 to the x. Now, there's two methods that we can do. For me personally, on problems like this, if we can make them the same base, it's easier. Same base. Okay, what do I mean by the same base? Now, if you can't make them the same base, we're gonna try logs. Okay, if I look at these two problems, if I can make the same base, the base are the big numbers. Those are the bases. The exponent is the x. So 16 can be a 2. I can make 16 into 2 because I know that 2 to the 4th power is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So instead of writing 16, let's write 2 to the 4th. Why do I want to do that? Because I have a 2 over here. Okay? So, change 16 to 2 to the 4th, but it's really 2 to the 4x. So 16 is really 2 to the 4x, so now I have the same base. Now, since we're solving for exponents, right? Exponents. Then I need an exponent over here. Well, that's easy. 2 is the same thing as 2 to the 1. Now this problem gets pretty easy. If they have the same base, 2 to the 4x equals 2 to the 1, then what I can do is just solve for x. I'm going to go straight to 4x equals 1. Okay, right? Because 2 to the 4x equals 2 to the 1. I can just cancel the 2's and say 4x equals 1. Exponent equal to the exponent. Divide by 4. I'm going to solve now. Divide by 4, divide by 4. And this answer is x equals 1/4. Okay, that's not too bad. All right, now let's look at b. So if I look at b, on b, what I've got is, again, 2 to the x and 4 to the 2x plus 1. So if I can make them the same base, it's easier. I don't have to worry about logarithms. And I know that 4 is 2 squared. Okay, so, all right, let's change 4 into 2 squared. Yeah, that makes sense. So instead of writing 4, I wrote 2 squared. Now, that's not really 4, it's 4 to the 2x plus 1, so let's put the 2x plus 1 in there, okay? So here's my 4. Okay, there's my 4 to the 2x plus 1. Now, equals a 2 to the x. All right, same base, right? I got 2 to the x equals 2 to the 2 times 2x plus 1. So if I have the same bases, I can cancel out the 2, cancel out the 2's, and say, all right, here's what I have. Because we're solving for exponents. So I've got x equals, and I can make this a 4x plus 2, and I can just solve, okay? I'm going to go minus 4x, I have a negative 3x equals 2, right? I'm just solving. Divide by negative 3, divide by negative 3, now an x equals a negative 2/3, okay? Now, on to the next one. What if, on C, we cannot make them the same? Can't at all, right? So one of the things we can deal with is getting rid of the exponent using logs. Okay, we learned this rule yesterday, that if I took the log of both of these sides, then it brings down the exponent, okay? So on C, if I take the log of both sides, if I take the log of 2 to the x, I just take the log of 2 to the x, and if I take the log of 3 to the x plus 1. So if I take the log of each side, what happens is it brings down the exponent. We learned that yesterday, okay? So it brings down the exponent, okay? So then, if that comes down, then I have an x times a log of 2 equals an x plus 1 times a log of 3. Now, one thing I didn't do is I didn't give it a base, right? Of forgot my 2 right there. Because I want to go base 10 so I can use my calculator. Okay, I want regular calculator log. Okay, so now if I want to solve for x, what I'll probably do first is just divide by, let's see, if I divide by log 2, no, let's divide by log 3. So to solve, let's divide by log 3, divide by log 3, and I'm going to use my calculator. What is this answer? That cancels. What is this answer? Okay, so what is log 2 divided by log 3? I'm just going to use my calculator. Log 2, close the parentheses, log 2 divided by log 3, close parentheses, and I get a decimal, about 0.63. 0.63 is good enough for me, so we're going to go 0.63x equals an x plus 1. Now it gets regular solving for x. Okay, so to solve for x, I'll go, okay, I've got 0.63x, that's what that was, 0.63. So to solve for x, I'll go minus 1x, minus 1x. Now decimals, I'm just going to use my calculator. What is 0.63? Subtract 1. I get a negative 0.37. X equals 1. I'm going to divide 1 divided by negative 0.37, and I get an answer about negative 2.7. Okay. Alright, I'm running out of room, so we're probably going to need to flip the page because there's lots of different ways to do these. And I want to do a few problems. I'm hoping that you're being quiet. I'm hoping you're paying attention because these are hard. Okay, let's turn the page. Alright, let's go all the way to page 161. Okay, let's go to page 161. Page 161, okay? Alright, let's go straight to, well, we can do 1, that's easy. And we can do 2, but what I want to do is go to 3. Okay, 1 is same base. You can go straight to cancel out, and go to 2x plus 4 equals 5x minus 8 and solve. I'm not going to do that. That's easy. You can do that, okay? Number 2, I'm not going to do number 2, but you can change that to the same base because 4 can be 2 squared. 8 can be 2 cubed, so I can have a 2 squared times a 2x minus 1 equals 8 is 2 cubed, okay, 4 is 2 squared, 8 is 2 cubed times x plus 2, and I can just solve for x, okay, but I'm not going to do it. I want to go to 3, because 3 is where it gets kind of interesting, okay? All right, now, let's go back to 3. Cannot make a 3 into a 5, and I can't make a 5 into a 3, okay? So they're different bases. I cannot make the same bases, so we're going to have to take the log of them. So here's what I'm going to do. I need to get the x plus 3 down. To get it down, I'm going to take the log of both sides. Alright? So we take the log of both sides. Take the log of this. So we take the log of 3 to the x plus 3 equals the log of 5. Alright? Why do we do it? The whole reason we do logarithms is to deal with the exponent. So now the exponent can float on down. We learned that rule yesterday. So the x plus 3 floats on down. So I get an x plus 3 times log 3 equals log 5. Okay? So I took the log of both sides to bring down the exponent. Okay, now, log 3 is just a number. It's a number in my calculator. Log 5 is just a number. It's just a number in my calculator. So what I want to do is to solve. So I'm just going to divide by log 3, divide by log 3. Okay, so use your calculator, okay? Log 3 divided by log 5, and I get an answer of about 0.68, okay? So I get an x plus 3 equals a 0.68. I'm just using my calculator, okay? Now, subtract 3, minus 3, minus 3, and I get x equals, well, use your calculator, 0.68 minus 3, and I get an answer about negative 2.32. Okay, these are kind of hard. Let me keep working with you, okay? All right, let's go to 5. 5 is a little bit unique also, okay? Now, in 5, before we do anything, a little side work, okay? On number 5, I'll put the side work here. Natural log of e is 1, okay? Natural log of e is 1, okay? Always. In fact, try it on a calculator. Go ln of e. Check it out. ln, here, let me clear all this so you can see it. ln of the number e is always 1. Always 1, okay? ln of e is always equal to 1. Okay, so that's going to help me. So let's go back to 5. Before I do anything with 5, this 12. This 12 is kind of annoying. So I'm going to get rid of this 12. So let's go start right off the bat. We'll divide by 12. Divide by 12. Just get rid of that 12, okay? Divide by 12, divide by 12. So what is 500 divided by 12? I don't know. 41.6 repeating, okay? So that means the 12's gone. I have an e to the 1 minus x equals 41.6, okay? Now, the way we're going to get rid of the e is instead of taking the log of it, we're going to take the natural log, because e and natural log go together. So I'm going to take the natural log. I'm actually going to go ln, because it is a log, but it's log base e, and I'm going to go ln of this. So if I take the natural log of both sides, okay? Two things happen. Two things. One, we take logs to deal with the exponent. So when I take the log of anything, it floats the exponent down. Okay, that's the rule. We learned that yesterday. So bring down the exponent. So I've got this 1 minus x, and I get this natural log of e. Well, natural log of e is 1. It's disappeared. ln of e is 1. I could put a 1 here. It's kind of a waste of time, but ln of e is 1. So that becomes 1. That's nice. Equals whatever the ln of 41.6 is. So a calculator, I was okay, what is the natural log? What is the, so we can turn this lamp on. What is the natural log of 41.666? So I get an answer about 3.73. So I'm going to round, and there's 100, 3.73. So this number is about 3.73. Okay, now to solve. Okay, so now it's just math. It's just solving for math. Even though we have decimals, no big deal. I don't really need the 1 there. So I'm going to go minus 1, get a negative x equals a 2.73, right? I'm just solving. Minus 1. I don't really need the parentheses. And then bring the negative over, and I've got x equals a negative 2.73, okay? All right. Let's move to number 7. All right, number 7 is different because it's a log equation. All right. I'm going to change it to exponential form. Okay, hopefully I'm not going too fast. If I'm going too fast, just have the substitute pause the video, okay? All right, 7. It's a log equation. So what I want to do is change it to an exponential equation. So I'm going to go 3 to the 2 power. 3 to the 2 power equals 4x, right? 3 to the 2 power. Remember, we're going to change it from log form to exponential form. Okay, that's right up on the board, right next to the overhead. Okay, so we're going to go 3 to the 2 power equals 4x. So we got rid of the log because we changed it from log form to exponential form. Okay, now this is a pretty easy problem at this point because 3 squared is 9. Okay, divide by 4. Divide by 4. What's that? 2.25, I think. 2.25 equals x. Okay, that's not so bad. Okay. All right, number 8. All right, number 8, they're both ln, ln. So what I can do is simply say that ln is equal to ln, so what's inside of here must be what's equal to that. It has to be because you've got ln of this and ln of this. You could take it to the e power. Never mind, now I'll get rid of it. But anyway, let's take, so I know that x squared plus 3 has to equal to 4. Okay. I'm going to go ahead and go minus 3, x equals 1. X squared equals 1, right? Square root. Now, normally when I take the square root, I would get a plus or minus 1, okay? That'll actually work this time, won't it? Yeah, you can't really do negatives, but that'll work. Plus or minus 1. Okay, how am I doing? Okay. All right, let's shift down to number 10. And then after we do 10, we'll do 11. I think we're going to be good. So number 10. So, number 10, I've got natural log plus another natural log plus another natural log. Okay, so what I want to do is let's put these two natural logs together. Okay, we learned that rule yesterday. We learned that if you add natural logs, you can bring them together as a multiply. Okay, we learned that yesterday. So let's go and rewrite this as a natural log of x times an x plus 2 equals a natural log of x plus 6. Okay? All right, I just brought them together. See the plus sign here? Let me highlight that so you guys can see it. Let me highlight that. So if I highlight that, here's my plus sign, but I brought it together as times. Okay, we learned that yesterday. So it's one of our rules. Okay, now I've got natural log of this, natural log of this. Well, what's here has to be equal to there, so the natural logs we can just get rid of and say, okay, what is x times x plus 2 equals an x plus 6. Okay, let's solve for x. Okay, so I get an x squared plus a 2x equals an x plus 6. Ooh, looks like I might have to factor. Oh, fun. I love factoring. So let's bring everything over. Minus x, let's go minus 6, minus 6. Okay, so I want to bring everything over and set it equal to 0 so I can factor. So I brought over the x, minus x, minus x. I brought over the 6, minus 6, minus 6. Okay, let's see what we have. Got an x squared minus a 1x minus 6. Okay, I can factor that, right? I can factor that. I can go x minus 3, x plus 2 equals 0. And I can solve. I got x equals 3 and x equals negative 2. Now wait a minute. I think there's a rule that says logs can't be negative, but so I think there's a rule that says logs can't be negative. In fact, maybe I can check that out on my calculator. But if I take the negative 2 and plug it right up there in the original, okay, I'm going to put the negative 2 right there. Okay, right there. So I think there's a rule that says logs can't be negative because they're exponents. So let's see. If I go natural log of negative 2, let's see what my calculator says. Oh, error, non-real. Well, so that means if I get a negative value, and if I plug it in and I get a negative log, I have to throw it out. So just x equals 3 is your only answer. All right, I want to do 11, and then I'll be done. Okay? All right, let's do 11, and then I'll be done. Okay, so in 11, we are going to first bring these two together. Okay, I want to bring these two together because I've got log of this minus log of this. But we learned yesterday that we can bring them together. It's a single log. So I'm going to rewrite this as log base 2. And I'm going to bring these together of x plus 5 times an x minus 2 equals 3. Okay? So because of the, oh, I made a mistake. That's divide by. Shoot. Hopefully somebody's caught me on that. It has to be divide by. Has to be divide by because of that. Almost made a mistake. Good thing Shayla was here to make sure I didn't make a mistake, huh? So, divide by. Yeah, so now what do? Well, I want to get rid of this log. So I'm going to change this to exponential form. I'm going to say, okay, 2 to the 3, okay, exponential form. I'll go 2 to the 3 power equals what's inside. I'm going to go from log form to exponential form. It's on the board. Okay, so I go 2 to the 3 power equals x plus 5 divided by x minus 2. Okay, so in exponential form, 2 to the 3 power equals what's inside. Okay, now let's do some algebra. 2 to the 3rd power is 2 times 2 times 2. 2 to the 3rd power is 8 equals x plus 5 over x minus 2. All right, if I have to solve for x, I'm going to go back to a trick I learned in geometry, and that is if I have a fraction equal to a fraction, because I made it 8 over 1, I can cross multiply. Okay, so I'm going to cross multiply, and I'm going to multiply 1 up over here, and the x minus 2 I'm going to multiply up here. Okay, so I'm going to get an 8 times an x minus 2 equals a 1 times an x plus 5. Okay. And then I'm going to solve, distribute, and get an 8x minus 16 equals an x plus 5, right? Because 1x, 5. Solve, I'm going to go minus x, and I'll go plus 16, plus 16. I'm running out of room, so I'll scoot it up here. Okay. So 8x minus 8x minus x is a 7x, and 5 plus 16 is a 21. Divide by 7 x is equal to 3. Okay, these are pretty hard problems, but you guys can do it. I have faith in you. Okay, so I'm going to stop there. You need to get your computers out. You need to do this. Don't goof off. Get it done, okay?